So we are going to record these lectures, and I'm going to post both the PDF of the lecture notes plus the videos as well. Okay, so that's it for D12. Oh, and one more thing, when you upload your homework, just go to Dropbox. And as of now, I have already opened a folder for homework 1. You can upload your work there. We are going to discuss about how to arrange your homework later on, but this is how you submit your work. Okay, so this is the PowerPoint I have on D12 to install your Matlab, which many of you already have. So that's good. So let's move to the overall plan of our semester. So as you can see, don't focus too much on this particular dates for the homework. I still need to figure out what is the best way to collect the homeworks. But these are the different classes that we are going to have. My hope is we are going to be done by end of September. There'll be some study break, and then there would be a 2-hour final exam. So that's the overall plan. I have divided up the course into like 5 modules. So the plan is to cover module 1 today itself, where we basically do the fundamental calculations on Matlab. And then we go into vectors. Vector is important because Matlab is a scientific programming language, but it talks in the language of arrays and vectors. So we have to spend some time on how to do vector operations on Matlab. Then we are going to do some hardcore coding for these 3 classes, which is called scripts and functions. In fact, this 3 and this 4, so 4 classes. In between, you are going to have the midterm exam in September. And then we'll look at a number of applications from Matlab, and then the final exam. And the final exam is going to cover the entire syllabus. You can stop me if you have any questions. Any questions right now? Okay, so let's move on to the actual lecture for today. Okay, so this is, make sure that you can see my entire screen. So on the left, I'm going to have the lecture notes, which I apologize, they're going to be handwritten for the first couple of lectures. Then I have nicer slides to share with you guys. But initially, we are just going to discuss about the different theoretical aspects of Matlab. So I have them as handwritten. But more importantly, I'm going to share my Matlab screen with you guys, and just open your Matlab window if you have Matlab on your computers. And as I start writing a code, just follow after me. But make sure that you can see the entire view of both the screens, both the PDF as well as the Matlab window. Okay, so let's start. So in this course, the concept behind this course is to initiate you guys into different design technologies. But to be frank with you, design is not a very good term to describe this course. The tools that you are going to learn, Matlab or later on Excel, many of you probably already know Excel, but in specific SolidWorks, those tools are going to be very crucial to you, very valuable when you become practicing engineers. Or even if you go into academia, go into research like I did, programming languages like Matlab is always going to be very, very useful. So don't just think of it as something that you need for your mechanical engineering designs. This is going to be a lifelong asset to you once you learn a programming language and you learn it well. So by programming, what Matlab does is something called scientific computation. So it can carry out the basic calculations. Like I have a calculator, it typically, well, the calculators that you guys use now or I am using now, it can do some scientific computation. But typically when calculators were developed in the 50s, 60s, it was just to run numbers. And that's just computation. Scientific computation is when you can actually do other stuff like symbolic manipulations. You can calculate the logarithms, you can calculate the trigonometric functions, etc. So the 2 building blocks to scientific computations. One is just the numbers, numerical computation, and the second half is symbolic computation. And in between the different functions like the trig functions, the logarithms, other kinds of functions, they sort of lie in between. uh, the programming language that you are going to use, need to know how to calculate those functions. Now, over the last 3-4 decades, we have had a number of scientific computation programming languages. Matlab is one of the main ones over there. We also have other languages like Mathematica or Maple, I already said Matlab. So yeah, Maple, Mathematica, Matlab, these are some common languages. And to be frank with you, if Matlab is the first scientific computation language you are learning, this would almost feel like a mother tongue to you later on. For me, I did do some Matlab initially, but essentially Mathematica is the first language I learned in graduate school. And I did my undergrad in India, and somehow in India, we were not really studying this kind of coding languages at that time. We did learn some things like C and C++ and Fortran, but they are a little cumbersome to use unless you are using them regularly. So Mathematica was the first scientific computation language that I started using, and I still prefer this, but it depends on the person, and it's very subjective, like which one you are going to use later on. But learning Matlab well would take care of most of the engineering problems that you are going to solve later on in life. What I have written down here is this. Numerical computation, Matlab is better at it than Mathematica. Symbolic computation, where you have a lot of unknowns like X, Y, Z, Mathematica tends to be better because it is better with dealing with algebraic equations than Matlab. But in general, both can do everything. So since I've been using Matlab for a while now I can sort of figure out, okay, Matlab is the better tool for this particular problem, or Mathematica would be a better tool for a different problem. But as of now, just focus on Matlab. That would take care of most of the engineering calculations. Okay, so I already covered this. So we are going to divide our syllabus into these 5 modules. Let's try and finish this first module today itself. But before I go into the main content, let's discuss about the homework schedule. And this is a question that I have for you guys. Would you prefer the homework to be due on Tuesday, like just before the class, or would you prefer it to be due on Thursday? How many of you want Tuesday? Raise your hands. Thursday? Okay, so more of you are going for Thursday. So today is Thursday, so the homework that I'm going to announce at the end of this lecture would be due next Thursday, just before the class. And I have some office hours, but feel free to just email me to set up any Zoom call, or if you are here, you can just stop by at my office as well. I'm at Crothers. Okay, so the word Matlab actually comes from this particular phrase, matrix laboratory. As I was saying, Matlab is good with numbers, and the way it deals with numbers is it tries to reduce every problem to arrays and matrices. Have you guys covered anything on matrix operation before in physics or mathematics before? Do you know what I'm talking about? Like, it tries to reduce everything into an array of numbers or a matrix of numbers and then does the work. So when Matlab was developed, which I presume should be in the 70s, the name was coined from abbreviating this matrix laboratory. Now, once you install Matlab, whatever you do should be stored in the default directory, which is documents if you are using a Mac, or it would be my documents on a PC. So if you look at the right-hand side of my screen on my Matlab window, this is the default directory that I'm using. Make sure that it is always under the documents and on Matlab, because if it is not, sometimes if you are trying to run a code later on in the semester, you might have some issues to figure out what should be the path for Matlab to access that code. So make sure that whatever you do is saved under that Matlab folder that have already been created once when you installed Matlab on your machine. Okay, so not much intro to cover. Let's try and look at what MATLAB does. I would start with very simple calculations initially, and later on we can. My plan is to write a very simple small code at the end of the lecture today. Okay, so let's not focus on the other windows right now. And if you guys have MATLAB on your computer, just open it and try to follow after me. Just let's focus on the command window. So the command window is more like a simple calculator. You can do any kind of calculation over there. So suppose I'm doing 4 plus 5. I type 4 plus 5 and I press enter, I get the number. But suppose if I'm typing 5 plus x, it doesn't recognize this variable x. So what do we need to do this? So somehow there was another small x stored in my memory, so it gave us some numbers. But typically to use x, you first need to define what is x. Suppose if it is 20. So x is 20. Now you can do 5 plus x 25. So to use the command window, it is a little more equipped than a simple calculator, where you can assign a number to the variable that you are going to use, and then you can use that algebraic expression to evaluate that expression. So, but this is not really much useful, right? You have to, typically in engineering, more so later on, you are going to deal with a number of repetitive calculations. And even if it is not repetitive, it is going to be much more complex than just 5 plus x. So what command window would be helpful for is when you are trying to write a code to solve those very complex problems, you can try out the smallest snippets from that code, like try out a proof of concept testing sort of. So if you're writing a big code, you take a part of that code out, try it out at the command window, see if it works. If it doesn't work, you know that something is wrong and you need to fix that. I'm telling you this right now because that helps you to appreciate what the command window is for, to test out different subparts of your main code. Eventually, you are going to write big codes, but command window is still going to be useful to you even 20 years from now. Because to debug a code, you need to figure out where the flaw is, where the error is. And you do that by running parts of the code within this command window. Okay, a few more things. Suppose I'm typing 2 plus 5, 7. Now, if I don't want MATLAB to output this 7, what I would do is 2 plus 5 and a semicolon. And then if I press the enter, it don't give us anything. Now, this is important when you are actually running a big code, because suppose you are doing a repeat calculation. You don't want the output to be shown every time it does a calculation. And you can suppress that output by putting this semicolon. Okay, couple of more things. So pi is a known function inbuilt into MATLAB. So MATLAB knows what pi is, 3.1416. I might not cover everything on the lecture notes, and that's why I'm going to share all these PDFs with you. So when you try to teach yourself the language, if you have any doubts, just look at the lecture notes and hopefully it will have enough explanation of what we are going to do. Okay, so I think I have covered most of this stuff. So yeah, log, sine, these are all different functions that you are going to use later on. MATLAB knows what log means. MATLAB knows what sine means. Okay, so again, I have already told you about this, the current directory. Make sure that the directory is under my documents and under MATLAB. If it is not, you need to fix that. Okay, before I go into writing a code, a couple of more things. If you come to this tab home at the top left of your MATLAB window, there is a thing called layout. So if you don't prefer this overall layout, you can go over here and you can play around with it. Now, in terms of the layout, what are we seeing over here? So this is the on the very left. This is the current folder, which is this MATLAB folder. So whatever code that you might write, typically it would be saved under this folder. So assuming that you guys just install MATLAB, it might look really empty to you. I have it all flooded out because all the codes that I have written over the last few months. So this is the current folder, the Matlab folder. This is the command window. What I have here is the editor window. You write your main codes over here, and we are going to do that later on today. So this is the editor window to write the codes. This is the command window to run simple calculations or some subparts of the main code. If you come to the right, this is called workspace. So what is workspace? It stores all the different variables that you are assigning values to. So for example, right now, without clearing anything out from my Matlab memory, I have these many variables with some values attached to them. So for example, right now today I assigned a value of 20 to x. So that 20 got assigned to this caps x. And over here, on the right at the bottom, you have the command history. I don't find that useful, but it depends on your personal test, like how you want to arrange all these windows. But the most important ones over here are these three: the current folder, which helps you look at the codes that you have, the editor window where you write your code, and the command window. Now, one quick thing for your final exam, which finally would be in October this time, you can use your own computer. So, and it's going to be an online test. I'm going to send out the questions before the test, and you can use your computer. So make sure that whatever we do in the class, you save them properly in your folder, because I'm going to let you access all the codes that you are going to write throughout the semester. And being able to access your own codes, the things that you have written yourself, would be very useful when you actually take the test. So make sure that you save all your work in a way that you can find them easily enough, like the way you name the codes, etc. Any questions? Okay. So I just covered the layout. Okay, a few more things. As I was telling you, on the workspace, you can see that some variables have been assigned some values. But of course, you are not going to keep them associated with those values. You want to clear them because you want to write newer codes and want to use those same variables again. So this particular page gives you sort of like a summary of all the different quick things that you can do. So for example, clear would clear the workspace, all variables are removed. So let's do that right now. Actually, instead of clear, I'm going to use clear all. So which is this one, clears all variables and functions from workspace. So clear just removes the variables. Clear all would remove the functions that we are going to write. And eventually, since we are going to write functions in this class, which is just a type of code, let's build the practice of just using clear all instead of clear, because clear doesn't do the entire work. If I do clear all and press enter, see the workspace has erased everything. So now, even if I type the caps X where I had stored the value 20, Matlab doesn't know it anymore. It's unrecognized. So clear all is going to be important for you. There is a thing called CLC. What CLC does is clears command window, command history is lost. So basically it cleans up this command window, and I really like it because I don't want this crowding of all the different inputs that we are doing here. So if I type CLC, and if I press and enter, the command window gets cleaned out. So these are going to be important, and what we are going to do, this is, don't worry too much about the meat part of this code, but this is the code that I was writing for my research. But on every code, you are going to use this preamble initially. So clear all removes all the variables and functions. Close all actually closes all the graphical windows. So later on, you will see that you can create graphics with Matlab. And those are sub windows that would appear away from your main Matlab window. So close all closes all those windows, all those graph sub windows, and CLC cleans up the command window. So this is a preamble that we are always going to use throughout this class. And this is just good practice, even when you write codes later on Matlab, even after this semester, keep on using this, because that takes care of many of the bugs that a program might face. Because if there is something in Matlab's memory about previously stored variables, you won't get the answer that you want, and you won't even know it sometimes. Okay, so this is more like an introduction. So let's start to write a code. Okay, so how do I? So basically, you can do it in a couple of ways. You can go to new script, and that opens this kind of window to you, an editor window. Or if you already have this window open, then you can just press the plus, and that would sort of like an internet browser. It would throw up another window. So to repeat again, or you can also do this. It's up to you. You can do a script here as well. So new script, we have a new window. So let's start to write a code here. So the code that we are going to write is basically this. So we are going to draw a circle of a certain radius. So that's the problem. But before we do that, as I said, the first thing that we are going to do with any code is write this: clear all, close all, CLC. And you guys can type after me. So this is the first preamble. Now the problem that we are going to solve is draw a circle of radius r equals to, say, 5 units. Now, a few things to note over here. I started writing this line. This is not a command to Matlab. This is just a statement that you would be writing on the code to remind you what you actually did in that code. Or if you are, for example, later on, years from now, if you are working for someone, you write a code. But 5 years down the line, someone else might be using your code, and that person might want to know what you actually did in that code. So this kind of comments are very useful on any code, and make sure that you always do that, because even in this semester, when you take the test, just knowing what you did is useful. So we are going to draw a circle of radius r is equal to 5 units. Okay, so let me now ask you a few questions. Matlab is just a tool, right? It's just a programming language, but you need to know the mathematics. And we are assuming that you already know the mathematics to solve the problems that we are going to solve. Matlab is just going to give you the tool on how to make it all look pretty, or if you have a number of repeat calculations, how to make those calculations quick enough. So to draw a circle of radius r, what are the informations that you would need? Anyone? So you're trying to draw a circle of radius r. So what is the basic information that you would need?
A center point?
The center point, that is right. What else? Now try to think of it in the form of, like, try to put yourself into the brain of MATLAB. Try to think of the algorithm that you are going to tell MATLAB to draw it. So it is basically trying to trace out the circumference, right? The outer periphery.
You need two
It is not,
variables.
say again,
You need two variables,
which two variables?
x and y.
You need x and y, right? So x and y are the coordinates of each of those points on the periphery, right? But to get each of those points on the circular curve, what is the information that you need apart from the radius? So basically, if I look at this cartoon over here on my PDF, I'm trying to trace this circle. I need x, y. What else do I need? R and theta, right? Because you are trying to look at the point on the circumference. And how do I look at the point? You guys know trigonometry. We know that, okay, for this particular problem, we are trying to draw a circle of radius r. But just knowing r is not sufficient. To get the coordinates of each individual point on the periphery, you need to know what is the angle of that point with respect to the x and y axis. So you need to know this angular orientation of that point. And as you vary the value of theta, you can cover all different points along this circumference. Make sense? Okay. Now, how many such points would you need to draw a circle? So we are trying to trace a circle. Of
Aren't
course,
you
we
just
are
going to
going to
need 4?
4.
Yeah.
Uh, okay, let's try out the number 4 first and see what happens. So to get 4 points, we already know that r is the value of the radius. We need 4 angles, right? So what happens if I just give it 4 angles? So let's look at that. So as I said, to look at the peripheral points, we need to have the radius and the angle. So let's write something that can look at the angles. So angles to look at the peripheral points. But before that, draw a circle of radius r. So let's r be 5. And I don't need r to be outputted out, so I use the semicolon. Okay. So let's try to have the angle as theta equals linspace. I'll come to it in a moment. So what linspace means. So 0, 2 pi. And you said that let's use 4 angles. So let's see what happens. But before we actually write the full code, since I introduced a new thing to you guys, linspace, let's see what that means. So if I now copy this, and this is how command window is going to be helpful to you guys, that you can test parts from the main code into the command window. So let's copy this particular line. Let's type it out on the command window, and let's press enter. So what we have are these numbers associated or assigned to theta. First of all, Matlab thinks of angles in terms of radians. So this is all in terms of radians. So that's why we had 2 pi over here, because 2 pi is the total 360 degree. So what this 4 does is divide that particular domain, 0 degree to 2 pi radian, into 4 different numbers or 4 different parts. So 0, 2.09 radian, 4.18 radian, 6.28, 32 radian. So what basically this means is from 0 to 360 degree, we now have 4 different angles. Okay, so you'd be testing these things out over here to figure out what actually you are writing here, because typically on the code, you just use a semicolon and you won't get anything out of the code unless you run the entire code where you are finishing up your calculations. So that's the first step, telling Matlab what theta values you are going to use. What is the second step? For the second step, again, think about the mathematics. So we are trying to trace all these points along the circumference. Theta is just sort of like an input parameter, which you need to figure out the coordinates. R is also an input parameter, but you actually need to do this calculation, right? You need to do the R cosine theta, and you need to do the R sine theta. So does this make sense to you? What should be the value of X in terms of R and theta? It's R cosine, right? Because this is the angle theta, this is X. If you think about finishing a triangle over here, just review your trigo learnings that you had before, and the X coordinate is the horizontal distance, which is R cosine, and the Y coordinate is the vertical distance, which is R of sine theta. So the location, or rather coordinates of the points along the circular periphery. So X would be R times cosine theta. Y would be R times sine theta. Make sense? We have already told Matlab that the radius is 5, and we have told Matlab that, okay, let's pick 4 angles. These are the 4 angles that we are going to use. And here we are figuring out the coordinates for those 4 angles, which are going to lie on the circular circumference, semicolon. So now we have the XY points. What next? We need to actually plot, because the question asked us to draw a circle. So we need to plot the circle. So to draw the circle, or to plot out the circle, we use a command called plot, and just X and Y, the information that you are trying to plot. Okay. So this is one way to comment stuff. If you look at my PDF notes, you can also comment stuff on the right like this, and we are going to do that later on in the class as well. Okay, a few more things. This is axis equal. What it does is just freezes the aspect ratio of your plot as 1:1. And then I think I have the title. So the title is, so it just adds the title. These things are not essential, but just so that you know what you plotted. So circle of radius R, lecture 1. Okay, so rationally, or if you think about the logic to this problem, I think this makes all sense. You assign some radius value, you assign some angles. Based on the radius and the angles, you tried to calculate, figure out the coordinates of the peripheral points, and then you plotted those peripheral points. So as long as you plot the peripheral points, you should get something that looks like a circle. But would you? Anyone has any issues with this particular code? Okay, so let's see what we actually get. But before running the code, you need to do a few more steps, which is this. So go to this editor tab. So we were in the home tab to open this new script, but now go back to the editor tab. You have to save this. So save as, and save it in a way that you can find them later on during the test or when you do your homeworks. So I'm going to call this, okay, so fall 2020 lect 1 code 1. Okay. Now there are a couple of ways you can run a code. Once you have saved whatever you wrote on the editor window, you can go to this run tab at the top and run it directly from there. Or you can type out the name of the code on the command window and press an enter. So we are going to do both of them, but for now, let's just use the run tab. So make sure that this code is open on your editor window, and while it is open, I press the run. So did you guys see something on your computer in terms of anything showing up, a plot? It would be a sub window that's going to show up. Okay, so for me, it showed up on the other screen. So I need to make sure that it goes over there. So anyone has any kind of plot showing up on the computer? Yeah, but I need to, I guess. Yeah. So this is what showed up on my computer. Does it look like a circle? It doesn't. Why doesn't it look like a circle?
Shouldn't have been x squared and y squared.
X squared, y squared. Why should that be? Because you are trying to plot the coordinates of the points that lie on the circle. You are not really, so you probably are thinking about x squared and y squared, thinking about what the equation of a circle is, which you're right, is x squared plus y squared is equal to r squared. But we are not thinking about that right now. We are trying to figure out the coordinates of each of these points and just plotting them out. We are not really solving for the equation of the circle. that information is actually inbuilt into this trigo calculation, because if x is r cosine theta, y is r sine theta, if you just do a rough calculation, x square plus y square would be r square, because cosine square plus sine square is 1. So that information is inbuilt into the mathematics that we did, but we are not trying to figure out the equation of the circle. We are trying to figure out the coordinates of all the peripheral points, or many of the peripheral points, to trace out that circle. Now, what is wrong with what we are doing here is this. We have too few points over here. Just having 3 or 4 angles won't really give you the entire circle. You need to have more points. So let's see what happens if I use more number of points. So suppose we use 100. And let's save this and then press run. Okay, so this is what the circle should look like. So what happened here is, with theta being 100, this is what Matlab computed as it ran the code. So it ran theta linspace 0 to 2 pi to 100. So this again means you are looking at the angular domain of 0 to 360 degree, and you are breaking it up into 100 parts. So it now has information for 100 values of theta, and this is what the output would look like if you could output the theta. So these are all the values of theta that Matlab now had, and it could figure out the coordinates for each of those theta values. So as you circumscribe the circle, the theta changes and it finds a new coordinate to plot. So now it has more information for the different x's and the different y's, for the different points on the periphery. So it becomes smoother. If instead of 100 you had something like say 40, save this and run it again. Now if I try to get this, it still looks fine, but if you actually look closely at this, you can see that it is all right, but it still has these deviations. It's not really entirely smooth. With 100 it was like looking like a circle without this kind of little undulations. So you get the point, right? So basically you need to have many points to trace out a smooth circle. Okay, so this is one thing, to write a code to get an output, and this is how you get an output. The graph would show up, the plot would show up in a second window. Now, before we end today, a few more things that I want to tell you about running a code. So over here, we were just using the run tab, right? But there is a second option which might be useful later on as you build your knowledge on Matlab. To execute the code with the runtime, you need to have this code open on this window. But if you don't have that, if you have already closed this, you can still run it by doing this. So you basically type out the name of the code, which you can get by looking at this particular current folder, which is just on the left. So the code that we just ran is fall 2020 lect1 trial 1. So fall 2020 lect1 trial code 1. So you look at the name from your directory and you type it out and you press enter. So if you can do that on your computer, you'll see that again you have that circle that we plotted, the bat circle with just 40 points show up on your screen as a sub window. So this means that you can use the run tab only when the code is actually open. And to open the code, once you have saved the code under that directory, you just double click on the code and it should open up. Yeah, took me a while. So you double click on the code to open it up and you can use the run tab, or you can just use fall 2020 lect1 code 1. And it does the same stuff. Okay. So this gives you a sense of how to frame a code, how to run it. Now, before we go any further, let's try out another cool thing today. So over here, I'm already telling Matlab that radius for the circle that you were supposed to draw is 5 units. But let that be an independent parameter, as in let Matlab ask us the question, like what radius we want to draw the circle with. So for that, this is what we would do. And you are going to use this a lot later on in the next few lectures. So input, and within the inputs, I'm going to write a question, which is basically Matlab is going to ask us the question when we run this code. So try to think of what the Matlab is going to think like, and what is the radius of the circle you want to draw. So this is the question Matlab is going to ask us. And quotes close, and this. So now let's save this. And if I run it now, let's see what happens. So I again went to the run tab. Okay. So it was not asking me a question as such, but there is a reason for that. I think the Matlab is frozen here. What, like, you can unmute yourself. What did you get?
Nothing showed up for mine.
Okay,
It
so it
didn't-
should.
Mine
Yeah.
showed it asked as a question of what is the radius of the circle.
Okay, okay. So I think my Matlab has unfrozen itself. So let me try it now. Okay, so yeah, so input, what is the radius of the circle you want to draw? Fine. And then let's save this and let's run this. So I get the question now. So suppose the radius is 10 units. I press 10 over there, and you should get the circle, which should show up on a different window again. So it's just a bigger circle, which you can track by looking at the axis. Okay, so whatever I wrote initially was fine. It's just that my Matlab went a little slow. But you should get this question show up as long as you have this single quotes on the two sides and this particular syntax. Okay, so this is the code that I wanted to write today. If I now go back to the lecture notes, you can see that I have included screenshots, which I again apologize is a little fuzzy, but in the later lectures it would be cleaner. But you can still read what I wrote over there. So basically, if you can't follow any of the lecture, you can just look at the PDF notes and try to type it out on your Matlab, and you should get the circle in this case. I have one more page added, which might come in handy later on in terms of the different inbuilt Matlab functions that it has. For example, log and sine and cosine. So for example, today we used cosine and sine, the two inbuilt functions. Okay, and one more thing to remember, Matlab always processes the angles in radians. So don't make sure that you like if you are thinking in terms of degrees, make sure that you do that unit conversion to radians. So try to write this code for drawing a circle a few times and see how it works. And essentially, you need to get a feel of this language first, and it should not be that difficult. Okay, so this is homework assignment 1, which I said would be due before the class next Thursday. Go through them, and if you have any questions, you can ask me on Tuesday. So basically some of the homeworks are going to be a little trickier than what the tests are going to be. So we have midterm exams and we have a final exam. The exams are going to be relatively easier compared to the homeworks. And for the homework, you might have to do a lot of internet search on figuring out different things about Matlab. And by the way, on this fifth question, there's a thing called modify the script file circle.m. I basically mean this file that we just wrote. So the name is different. Make sure that you understand that. So you might have to do your own personal search through the internet on Matlab to figure out some of the homework questions because they're just a little bit more challenging than the homework than the exams. But if you have any questions, feel free to just email me and let me know. Okay, before we end this call, any other questions that you might have? Okay, so hopefully we will have a great semester. I'm sorry that we cannot have the in-person classes, but MATLAB being a programming language, I think even if we share the screens, it's the same thing. I want you guys to run your MATLAB codes after me and make sure that you get a feel of the language as you go through the class. Okay. So I'm going to stop the recording right now, and I'll see you guys on Tuesday.